The James Webb Telescope, more than 1 million miles from Earth, is revolutionizing our understanding of the universe. This incredible instrument is revealing hidden secrets of stars, galaxies, and exoplanets that were previously inaccessible to observation. Its discoveries are not only astounding in their depth, but also challenge many established theories, making science even more exciting. Historical context and the creation of JWST. The idea for JWST began in the late 20th century as a follow-up to the success of the Hubble Space Telescope. Scientists sought to create an instrument that could look farther back in time, observing the light of the first stars and galaxies. The project faced numerous technical challenges, from creating a mirror made of beryllium coated in gold to developing a cooling system for the infrared sensors. After decades of labor and many delays, JWST was launched in December 2021, becoming a symbol of human perseverance and the pursuit of discovery. Technical features of JWST. JWST is equipped with 4 main instruments. NIRCam near-infrared camera for observing distant galaxies and star clusters. MIRI mid-infrared instrument for studying cold objects such as dust clouds and exoplanet. NIRSPEC, a spectrograph capable of analyzing thousands of stars and galaxies simultaneously. FIGIS or NIRIS for precision pointing and spectroscopy. Its 6.5-meter diameter mirror allows light to be collected with incredible precision, making JWST the most powerful telescope in history. Revolutionary discoveries. Cosmic Smile, the collision of galaxies ARP-107. JWST observed the collision of 2 galaxies 465 million light-years away. The event, called ARP-107, surprised scientists with its smile-like shape. Infrared images showed a bridge of stars stretching between the galaxies and areas of active star formation glowing with orange and red hues. 2 effects of collisions. The compression of gas clouds accelerates star formation, but some of the gas dissipates, slowing star formation in other regions. Seyfert galaxies. ARP-107 belongs to a class of active galaxies with powerful black holes at their center, making them ideal objects to study. Galaxy M83, a star factory. M83, located 15 million light-years away, is surprisingly active. At its center, JWST has detected dense clusters of bright blue stars. The spiral arms contain star-forming regions rich in complex molecules such as aromatic hydrocarbons. These substances are key building blocks for the formation of new stars. Protostellar jets in the Snake Nebula. In the Snake Nebula, 1,300 light-years away, JWST observed unique jets of gas ejected from young stars. These observations confirm theories about how stars inherit the rotation of their parent clouds of gas and dust. New horizons in the study of exoplanet. WSP-39b, a world of contrasts. WSP-39b, a gas giant 700 light-years away, is a planet with a unique climate. One side is permanently facing the star and is heated to 1:5 OF, while the other side is in perpetual shadow. Atmospheric circulation. JWST has detected winds carrying heat between the sides of the planet. Chemical composition. Traces of water, carbon dioxide, and sulfur dioxide have been detected, helping to understand processes in the atmospheres of exoplanet. Storm on brown dwarfs. Brown dwarfs, such as WISE 1049a and WISE 1049b, are intermediate objects between stars and planets. JWST has discovered turbulent clouds of hot sand moving at incredible speeds in their atmospheres. These studies help us understand how such objects form and evolve. Each JWST discovery is not only a step forward for science, but also a reminder of our place in the universe. These observations inspire scientists and ordinary people alike by showing how grandiose and amazing our universe is. The beauty of space imagery is awe-inspiring and inspires a desire to continue exploring the unknown. JWST will continue its work observing the most distant galaxies, exoplanet, and dark matter. Its research will open new horizons and help answer fundamental questions about the origin and future of the universe. The James Webb Telescope is not just a scientific instrument. It is a window into the past and future of the cosmos. Its discoveries show us how large and complex the universe is and remind us that we are only beginning to understand its mysteries. The James Webb Telescope is not just a technological marvel, but a true breakthrough in our understanding of the cosmos. Each of its discoveries reminds us how complex and beautiful the universe is. It allows us to look into the depths of space and time, to see stars and galaxies as they were billions of years ago. It inspires us to think about our place in this grand picture and to keep exploring the unknown. It is amazing that through science we are witnessing wonders that were previously only available to the imagination. If you enjoyed this fascinating journey into the mysteries of the universe, don't forget to subscribe to the channel so you don't miss new amazing stories about space. Click on the subscribe button and the bell to always stay up to date with the most exciting discoveries. Your likes, comments, and subscriptions motivate us to create even more interesting content. See you in the next videos.